Hello, I welcome you all for this new session on influence coefficients. Okay, it is influence coefficients. It is required in some of the numerical methods. For example, in the Dunker-Lewis method and in the matrix iteration method, these influence coefficients are required to find the natural frequency of the systems. Influence coefficients are the displacements, static deflections of the masses due to the unit force applied. For the given n degrees of freedom system, there are n square number of influence coefficients. Okay, influence coefficients are denoted as Aij, where I is the deflection at the mass I due to the unit force applied at the mass j. For example, if you take any system, for example, if you take this system here in this numerical problem, it has three masses. Mass 1 it is 4m, mass 2 2m, and mass 3 is m. For it is a 3 degrees freedom of system. It is a 3 degree of freedom system. For 3 degree of freedom system, 3 square means 9 number of influence coefficients. A11, A12, A13, A21, A22, A23, A31, A32, and A33. What is Aij? Aij means it means that the deflection at the mass I due to the unit force applied at the mass j. For example, if you take A11, the first subscript is 1, the second subscript is also 1. First subscript, it is deflection at the mass 1 due to the unit force applied at the mass 1. Similarly, A21, it is the deflection at the mass 2 due to the unit force applied at the mass 1. Okay, so Aij is equal to deflection at the ith mass due to unit force applied at the jth mass. For n degree of freedom system, there are n square number of influence coefficients. For the given system, you need to find all the influence coefficients, okay, which is required in the numerical methods like Dunker-Lewis and matrix iteration method. Okay, for different system, there is a different procedure to find the influence coefficients. We will go one by one. Let us take this mass spring system. Okay, this is a 3 degree of freedom systems. For 3 degree of freedom system, there are 9 number of influence coefficients: A11 to A33, A11, A12, A13, A21, A22, A23, A31, A32, A33. Okay, when the mass 1 is pulled, so the displacement of the mass 1, mass 2, and mass 3 all are same. So A11 is equal to A21 and A31. See here, when the unit force is applied at the mass 1, then the displacement is same for the mass 1, mass 2, and mass 3. So A11 is equal to A21, A21 is equal to A31, and by some method Aij is equal to Aj. See here, A11 is equal to A21, that is equal to A31, and Aij is equal to Aj. By that method, A21 is equal to A12, A31 is equal to A13. So by finding the A11, we know 5 influence coefficient for this type of problems, mass spring systems. Okay, how to find A11 now? A11 is equal to force is equal to K into X. Force is equal to K into X. So X is equal to force divided by, let us take a pen, MS. Okay, force is equal to K into X, where X is the displacement, so force divided by it is K. But in the influence coefficient, it is for the unit force applied, so force is always unit, so 1 by K. It is the reciprocal of the spring stiffness. Okay, for the mass 1, when it is pulled, only this spring will get elongated, so this spring stiffness is 3K. How to find the displacement here? X is equal to 1 by K, 1 by reciprocal of the spring stiffness. So only this spring get elongated when this mass is pulled. So it is 1 by 3k. A11 is equal to 1 by 3k. Okay. When it is pulled, when the mass is pulled, the same elongations will take place for the mass 2 and mass 3. So it is A21 is equal to 1 by 3k, A31 is equal to 1 by 3k, and Aj is equal to Aj. By this, A21 is equal to A12 and A31 is equal to A13. So by finding A11, now we know all the 5 influence coefficients. Okay, keep it in mind. If force is applied in the mass 1, then the same displacement is there for mass 2 and mass 3. So A11 is equal to A21, that is equal to A31, and that is equal to A12 and equal to A13. Okay, now we know 5 influence coefficients. Out of the 9 influence coefficients, we know 5 influence. Now next, you apply the force at the mass 2. When you pull the mass 2, then these two springs get elongated. These two springs get elongated. So to find the spring stiffness, we are using these expressions. 1 by k is equal to equivalent spring stiffness. 1 by k is equal to 1 by 3k plus 1 by k. Okay. Again you find the spring stiffness. Again you find the displacement of the mass 2. This time it is A22. This spring stiffness displacement, it is A22 because the force is applied at the mass 2. So what is the displacement at the mass 2? It is A22. Okay, A22 is equal to A32. The displacement when the force is applied at the mass 2, the same displacement will take place at the mass 3. A22 is equal to A32. A32 is equal to A23. So by finding this displacement when the unit force is applied at the mass 2, you will get 3 influence coefficients: A22, A32 and A23. Okay. How to find A22? That is 1 by Ke. What is Ke here? When the force is applied at the mass 2, two springs get elongated, 3k and k. So 1 by 3k plus 1 by k, it is 4 by 3k. We know that 1 by k is equal to 4 by 3k. Okay. The same value A32 is same value and A23 is also same value. Next. Okay. So far we have find out 8 number of influence coefficients. One more remaining, it is A33. When the mass 3 is pulled, all the springs get elongated. So to find the equivalent spring stiffness, 1 by 3k plus 1 by k plus 1 by k. So 1 by ke, it is nothing but it is A33 value. See here, A33 value 1 by 3k plus 1 by k plus 1 by k. It is 7 by 3k. Okay, this equivalent spring stiffness, the reciprocal of this equivalent spring stiffness, it is A33. Okay. Now what you have seen here, when the mass 1 is pulled, all the masses displaced with the same magnitude. So A11 is equal to A21, that is equal to A31, that is equal to A12 and that is equal to A13. So the reciprocal of this spring stiffness 1 by 3k, that value is same for all the A11, A21, A31 and A12 and A13. Next, when the unit force is applied at the mass 2, then A22 is equal to A32 and A23. Okay, when the force is applied at the mass 2, then these two springs get elongated. So 1 by 3k plus 1 by k, that is equal to 1 by ke. That is 1 by k is equivalent spring stiffness. Okay, that is equal to A22, A32 and A23. When the force is applied at the mass 3, all the springs get elongated. So the reciprocal, to find the equivalent spring stiffness 1 by ke, that is 1 by 3k plus 1 by k plus 1 by k. Okay. Okay, this is the procedure to find the influence coefficients for the mass spring system. Okay, the procedure is not same for all the systems, it is only for the mass spring system. In the next video we will see for some other system. Thank you.